Hi everyone, it's Mr. Jensen. Today in class we went over graphing, so I would like to do a graphing review video to reinforce those ideas. So here I have just your basic graph, and I'll just get started on kind of like labeling parts of it. So you definitely need to know the parts of a graph as I refer to them in the future. So if I start labeling it, I would start by labeling my y-axis. I would start labeling my x-axis. Up here, we would put a title for our graph, and now we have our basic three main parts of a graph. I always like to make sure everyone knows how a basic graph will work, where this corner here is going to be your lowest point of your x or your y. As you move vertically up, your y variable will get higher, and as you move to the right, your x variable will also get higher or increase. So your lowest point of the graph is going to be this point that I'm coloring in here, and your highest for your y goes up, and your highest for your x goes generally to the right. All right, so what do you place on the y-axis and the x-axis? I have written over here some already made words. Your y-axis is going to be your dependent variable, and your x-axis is going to be your independent variable. So today in class we discussed dependent variables versus independent variables, and we also mentioned that in earth science, a lot of the time your independent variable is going to be time itself, in seconds, minutes, years, centuries, etc. So which one is the dependent variable? A dependent variable is going to be the variable that the scientist is testing. And the independent variable will be the variable that the scientist will change each trial. So in the case of time being your independent variable, the scientist will change how many seconds have gone by for each trial, or how many minutes have gone by for each trial, or how many hours, etc., etc. Yesterday, though, we did an experiment with density where we didn't use time and we used a material, and we were trying to test its density. So based off yesterday, if we were to create a graph, and I'll zoom in a bit, our independent variable yesterday with our density lab was the actual material that we used. So as scientists in our experiment yesterday, we were changing the material. We changed it from a wood block to a plastic block to a metal block. And what we were testing yesterday was, I think I have to fit it in here, was density. So each time we changed our variable from material to material, our density was being tested and was being changed. And so those are our basic parts of our graph with an example that we used previously. So let me clear these out. Delete, 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 delete. Let me erase what I have going on now, so we can get into the 4 types of graphs. And you know what, I'll put back y and x for us. All right, so the first graph that we went over today in class was what we call a direct graph. So in this case, our direct graphs in general, our direct relationships, will usually start at 0, 0. This is the lowest point of the graph, and as x goes up, so as x gets higher or increases, y will also increase. So what this is going to look like as a direct graph is your kind of like straight diagonal line across. So as y goes up, x also goes up as well. You can also see this drawn a little differently as we saw. It just will have a different rate of change, but this would also be a direct relationship. As as x goes up, y also goes up or increases. And this kind of graph was direct. I guess we'll do an example for each of these. So the classic one usually is time spent on schoolwork. So we'll test the time spent on schoolwork. It starts with a low amount and it ends with a high amount of schoolwork. So this might be directly related to your grade in some cases. So as you spend more time on your schoolwork, your grade also increases. And here in the beginning, if you only spend a little bit of time on your schoolwork, then your grade may be low. All right, moving on to our next relationship. This relationship, our second relationship that we learned, was the inverse or opposite of that. It is called an indirect, or inverse. Inverse. So in this case, we have our x and we have our y. Y will actually usually start higher. So y will start usually up here instead. So at the beginning, and say this is time, and this is amount of candy that you're eating. As time goes by, you have a smaller amount of candy. So as x increases, y is actually decreasing instead. So as time goes by, you're eating candy for 1 hour, you're eating candy for 2 hours, you're eating candy for 3 hours. Maybe you're feeling sick because eating candy for 3 hours doesn't sound like a good idea. But as time increases, the amount of candy that you have will decrease. So we call that an indirect or inverse relationship on a graph. And again, maybe you don't eat it perfectly steadily. Maybe you're not eating it at a steady rate. So maybe at the very beginning, in the first hour that you're eating it, you eat a lot of candy. So your amount of candy, your y, diminishes very quickly. But then you slow down and you eat less and less, but you're still eating it, and the rate's a little bit lower until you run out of all your candy. Right, so both of those examples, the straight diagonal line was more of like a steady rate decline or decrease, and this one is more, I guess, exponential at a different rate. All right. Moving on to the third type of graph that we saw today, and this is called cyclic. So this one also usually goes with time. As we discussed, most of the time our x-axis or independent variable will be time. And the most popular version they use of this is the tide. And cyclic or cyclic graphs and relationships are usually predictable. So that's something really important, that we know that we can predict cycles. The cycles of the temperature throughout the entire year, the cycle of the sun's height in the sky throughout the day, and most popularly, the high tide and low tide for a day, a week, a month, etc. So this means while x is getting higher or increasing, that the y value, or the y variable, or dependent variable, will increase and then decrease in a repeating pattern. And any cyclic relationship is, most importantly, predictable. That's why we know the tide. We know the tides beforehand. So each day you can check the tides and you'll know exactly what time high tide is one day. You'll know what high tide is the next day. This is cyclic. Finally, we have our last and fourth relationship in a graph. And this one is called static. So here you'll have your x, and here you'll have your y. And I'll use a different example for this besides time because we use it so much. We can use mass, and we could use density. Right? So we can tie in what we know about density for a material. So it could be any material really. I feel like I've been using this example for density. We use halite. So the mass of halite, right? So say your mass of halite is low, right? Because this is the lowest part of a graph. This is the highest part of the graph. So no matter what our mass of halite is, will it ever change density? The answer is no. So as the mass of halite increases and increases and increases, no matter what, its density is going to stay exactly the same. And that would be a very popular option to explain a static relationship on a graph. All right, if you have any questions, please let me know in Google Classroom or in person when I see you next. All right, thanks for watching if you're reviewing, and have a good day.